right, now that we spent this entire half of the course talking about dynamics networks and particle simulations and dot networks and all that stuff and dealing with different types of solvers, I thought that now it would be really cool to introduce you to the custom solver, which is a node that's designed to allow you to build your own solvers that do propagate completely custom behavior. So what we're going to do is we're going to build a infection setup, and it's going to be a really cool way to kind of grow particles across our geometry and create some really interesting abstract effects. And I think you'll find, this is just the tip of the iceberg when it comes to what types of things can be done with the custom solver. So hopefully it sparks some ideas and some inspiration as we learn what amazing power for abstract effects lies within the custom solver. All right, so over here in Houdini, I want to start off by throwing down a grid. And this is going to be the surface that we spread our infection across at first. So the way this generally works is we are going to scatter a bunch of points. So I'm going to throw down a scatter. And let's just increase the density of this to something like 100,000. And I'm just going to turn off relax iterations just so that it looks a little bit more random. And then, so the other thing we need is a starting point. So I'm just going to throw down an add. And this add, I'm just going to hit this plus icon here. And if you see, it is creating a point here for us at the origin. It's kind of small, but it's there. So the way this generally works, we want to create two attributes. We want to create one attribute on each of our geometry. So I'm going to start off by using an attribute create. And this attribute I'll create is called seed. And I'm going to set it to an integer value. And I'm going to leave the seed value set to 0 on these scatter points over here. And on the right-hand side, I'm actually going to alt drag this seed attribute over, wire it in. And we're going to set this value to 1. So basically what we're saying is that this one point that we have over here is a seed, and then this all these points over here are not seeds. Essentially, it's like we're using this integer attribute as two separate groups, but we don't really actually need to create groups. We can just reference these attributes. And now the way the solver works is the solver will allow us to more or less look up every single frame, whether basically we're going to iterate over all of these points, and for every single point in this scatter, we're going to say, hey, are you nearby another point that is a seed point? And if you are, well then, you're going to catch the infection, and then you're going to become a seed point as well. And when we feed that through the solver that's updating every single frame, you get this sort of spreading effect where it looks like this infection is sort of propagating through all these points. What I want to do first is just basically implement this in a way out here in SOPs before we throw it inside of a solver, just so we can see what's going on. So I'm going to create a point VOP. And we're going to do all of this infection spreading inside this point VOP. Before, just to help with the visualization, what I want to do is create two colors. So I'm going to color the uninfected points. I'm going to color them blue, and then the seed points, I'm going to color them red, like that. So now what I want to do is merge these together. So if I merge them, just grab these two guys, put them together. You can see we've got one red point in the middle of all these blue points, and we can spread our infection out from that red point. So inside this point VOP is really where all this logic is going to occur that allows this to happen. So let's just wire this into the first input, and let's just jump inside our point VOP. So the first thing we want to do here is we want to make sure that whatever we're doing, we're only running over points that have a seed value of 0. So we're going to do that by binding in our seed attribute. So let's do a bind. And I'll just type in seed up here. It's an integer attribute. And now what we can do is use an if statement. And the way we use an if statement is we just throw down a block. It's called an if block. And so basically what this is we bring in a condition into the if block, and basically we supply it with a condition. Basically we say if some statement is true, we wire that in here, then you do whatever's inside of this if this blue blob here basically. And the way that we can determine if we are getting a true value is we can actually use a compare node to compare this seed value to some other value. So if I throw down a compare and I wire in the seed value into input 1, we can say, is this seed value equal to 0? That's basically what this says right now. We can test all these different ways. We can say less than, greater than, but we're basically just asking if the seed value equals 0, well, then that gives us a value of true, which means we can do whatever's inside of this if statement. So for example, we could say we would want to set the color to be something like green. So let's throw down a constant. I'm going to set it to a vector, and we'll just set it to 0, 1, 0 for the green value, red, green, blue. And then if I throw in this geometry right here, I can wire this constant in to the first part of this block begin, and then wire this out to the color. And you can see that all the points except for that one red point that we created, our seed point, they've turned green. So it means that this if statement is working correctly. It's detecting what's a seed, and then allowing the block statement to the if statement to work properly. So I'm just going to disconnect this for right now. We'll actually use a constant vector later on when we want to color our particles red, once we get our infection to start spreading. So I'm just going to take this out. The next thing that we want to do is we want to do a lookup. So we're saying if this seed equals 0, let's look up the points around it and see if any of the other ones are actually have a seed value that's equal to 1. The way that we look up other point attributes in a radius around our points is to use a point cloud. So we want to use the PC open node. And what that allows us to do is feed it in a file, and we want to take in op input 1, which is basically the geometry that's flowing into this first one right here. So basically what we're working on right now. And we want to use the position of our current point to look up into this point cloud. Now, we want this point cloud to actually be happening inside of this if statement. So the way that we do that is similar to how we wire this constant in. I'm just going to wire position into this variable 1 in. And now once I route that out to position, you can see that blue blob kind of goes around the PC open and encloses it, so that we know that this point cloud lookup, or this point cloud open, is only really happening wherever this if statement is true. So now what we can do is actually filter this point cloud to look up what the what the seed value is. So the way we do that is using a PC filter. And I'm just going to wire the handle in here. So this handle is sort of what is passed along when dealing with the point cloud. And now I can say the channel we want to look up is the seed channel. So back over here on our PC open, we're basically saying for every single point that you iterate through that is a seed value of 0, we're going to look at the current position, and we're going to search around it in a certain radius around each point. And this radius is determined by this value right here. And then we actually have a maximum number of points that we can actually look up. So we can change this to say like, oh, I only want to look up the 5 nearest points within this radius. So these are two important values that allow us to sort of limit the scope of what this point cloud is actually looking up into. So I'm just going to put these values back to default, and we can modify those later, but just wanted to, briefly touch on what those are actually for. So the next thing is we want to do another if statement. So I'm just going to keep dragging this out to the right here, because we're going to build out another thing in here. And what are we going to do is we're going to say, well, we want to ask if there are any points inside this PC filter that are greater than 0, meaning that if the seed value is greater than 0, we want to do something else like, set its, change its attributes to make it also infected. So we do another compare here, just like we did before, and we feed that into another if block, like so. So the PC filter is looking up seed. The signature is actually an integer channel because seed we set as an integer. What we're going to say is if this seed value is actually greater than 0, then do whatever's going on inside of this if statement. So we've got an if statement inside of an if statement. It can get kind of confusing, but that's sort of kind of how the logic flows when you're building your own custom solvers. You got to kind of think about it in this way. So the next thing we want to do here is just bind out those attributes. So what we'll say is we'll throw down a bind export, and we're going to bind this to, see, it's not inside here, but we're going to add a constant value that allows us to bind this out. So let's throw down the name. The name we want to bind out to is seed, and the type is an integer value. And then what we want to do is set that value. So we're going to throw down a constant. This is going to be a constant integer, and we're setting its value to 1 because we're making it we're just saying it's true that it is a seed now. So if I wire that into this first variable and wire this out, you can see now that our seed is kind of restricted to the inside of this blob, which is good. So that means that it's going to be setting the seed value to 1 if all these conditions are met. And then the other thing that we want to do is just change the color to red. So I'm going to just switch the 1 over to the X value here. And I'm going to wire this into our block begin as well. And then I can just bring our geometry output over here and wire that out to color. Now you can see that a few points have spread over here. So if I go back to our PC open, I can change the search radius, but nothing's happening because it's only looking for a maximum number of 10 points. But if I increase that maximum number of points, you'll see that now we can sort of increase how many points this is looking up all at once. Now, if we have a super high value of points and search radius, as we go through our solver, this is going to kind of it's going to grow very rapidly and maybe not very interestingly. So I like to keep these values pretty low. But I also like to make it so that I can control them up on this point VOP level and not have to dive inside. So the next thing I'm going to do is I'm going to just promote the radius and the max points. So I'm just going to millimouse radius and say promote parameter. And I'm going to millimouse on this max points dot and say promote parameter there as well. Then what I want to do is, if we go out here, we can see that we can adjust all that stuff and we're picking up more points, and that's cool. But it's only doing this just once. And what we want to have this happen is we're going to kind of reset this every single frame and have it do the whole thing inside this point VOP one more time, every single frame. So the way we do that is using a solver. The solver is very much like the SOP solver that we used in DOPS in a couple of our examples. If you dive inside, you see that you get your 4 inputs from these inputs here on the solver, and then you get this node called previous frame. And this is basically bringing in the previous frame from your simulation so that you can run the same operation on it again and again and again. So what I'm going to do is I'm actually going to copy this point VOP that we created here, and I'm going to dive inside the solver and wire it up to the previous frame. Next thing I want to do is create an output node, just because I find that when I'm messing around in here and if I've added more nodes or anything like that, this example is pretty simple, so probably won't have to, but I find that having this output node here is great because no matter what node you have selected or highlighted with your display flag on, it'll always export this output node. So now if I wire in this merge to the solver and set the display flag to the solver, zoom out here and click play, you can see that that infection is spreading through our geometry. It's kind of just making a circle, but you can see how the edges are a little bit uneven. And this is where it's cool to start messing around with these attributes we created over here with search radius and number of points. But they're not easily accessible on our solver. So let's just edit our interface a little bit so that we can have those attributes up here, or those parameters up here on our actual solver object itself. So I'm going to hit the gear icon here and choose Edit Parameter Interface. And then I'm going to just dive inside the solver here. I'm going to grab my point VOP right here. And I think what I'll do first before I do this is let's create a separator. Where's that? There we go. I'm going to throw a separator down. And then I'm just going to grab the search radius and the number of points. I'm just dragging them in there. You can see that they appear. I hit apply. And then these values turn like this kind of teal color. That means that it's got that they are hooked up to our the parameters that are on our solver now. So if we hop out here to our solver, you can see we've got our search radius and our number of points. And it's kind of hard to see, but there's a little line, a little separator line that I put in there between these two, between the upper part and the lower part of our solver. So I'm going to hit accept. And now I can do stuff like, let's bring down the search points. You can see that this changes how the simulation runs. So if maybe I try it with 4 search points, you can see that we get a much more branchy growth. And then it actually stops because it doesn't have like enough radius to continue. So maybe if I dial that up a little bit, it continues and it stops. So, you know, I find that even though I think that there should be 4 points within a certain radius, like, you know, 4 of the points on one of these points could be actually closer to non-seed points than seed points. So it does help to kind of crank this up a little bit. So let's try a value of like search radius of 0.1. Doesn't necessarily need to be high. Really, the number of points down here is going to be sort of the determining factor. Let's bring this back and click play. All right, 7 seems a little bit high. Let's maybe try 5. And now you can see we're getting a really branchy, like interesting growth across our surface. And so all this stuff can be kind of interesting to try and balance, but basically you're going to be messing around with the number of points, and you're also going to want to mess around with how dense your scatter is, and really the combination of your scatter density, your search radius, number of points, and also you could, you know, those are all going to determine how fast your how fast and how detailed the spreading of your infection system are. So other things, like if you wanted to actually speed up your infection, if I suppose I wanted my infection to happen twice as fast, what you could do is increase your substeps to 2, and then it would maybe be solved by frame 120. If I let that, you can see that I'm just going to go back to it's solving. So if I go back here, you can see that now it's going much faster and solving much faster because it's going through the solver twice because we gave it 2 substeps. So I'm just going to set that back to 1. And now what I want to do is maybe put in some more, some different geo. So I'm going to go back up here and maybe throw down the pig head and see what the infection system looks like when we grow it along the pig head. So let's wire the pig head into the scatter. And the next thing is I want to, I need to move this point, because this point right now at the origin is nowhere near any other point. So it'll never get looked up by the point cloud. So if I hit play, nothing happens. But if I do something tricky like throw down array, the ray sop, oops, and I wire the add into the left input and the pig head into the right input. And then I just wire this into our seed attribute right there. You can see that the, well, the point hasn't moved yet, but if I choose over here minimum distance, it moves that point to somewhere inside the pig's mouth, which is fine for now. We can put it anywhere we want. If we just simply grab this, select our manipulator, and maybe template the pig head. By moving this around, you can see that it's kind of hard to see right now. Let's see if we can go. hide that. You can see now I've moved that that ray point onto the ear, and you know, wherever I move it, it's just sort of snapping to the surface of the pig somewhere. But I'm just going to put this back to 0 for now, because it might look cool to have this infection coming out of the pig's mouth. We'll have to see. Might be a little bit gross, but this is Houdini. We can make gross stuff in Houdini. It's all good. So let's go back to frame 0 and click play. So now you can see that we've got our infection system growing out of the pig's mouth and just sort of infecting across his face and slowly engulfing his entire head, which is cool. But how can we put this into good use? Really, right now, all we've got is just sort of a just 2 different colored points. So maybe we could use this to actually create some geo that looks like maybe like some sort of goop that's kind of growing across the surface of the pig head. So what I want to do first is let's delete out the points that are not seed points. So to do that, I'm going to throw down a delete node. Wire that in here. And instead of in primitives, I'm going to select points. And I don't want to delete by pattern. I want to delete by expression. Then I'm going to just use the expression at seed is less than 1. So any point that is less than that has a seed value of less than 1 is going to be deleted. And now, because we're after our solver, you know, we still have all of the points up here, and that's not going to change. We're not affecting our solver since we're downstream. We're just deleting points out of it that we don't need right now. So we're essentially growing these points at this point. You can see them growing across. And you know, if I wanted this to actually, I do want this to maybe fully engulf the pig head. So maybe what I'll do is, I'll just, instead of increasing the amount of substeps, I might just add another point so that it's also infecting maybe from the next the pig's lower neck. So let's just up here on the add node, I'm going to hit the plus button and add another point here. And then I'm just going to look at the pig head, and then maybe I'll just, with the add selected and the manipulator selected, I'm just going to drag this other point down over here. So it's like sort of underneath the pig. And then that ray should project that point back up onto the surface. And you can see it right here. It's just on the bottom of the pig right there. So now when I go back and run the solver, hopefully it will fully enclose the pig head. Almost. The other thing I'll do to get it to speed up is, I think what I will do is add a little bit of substeps here. So I'm just going to increase the substeps to 2. Click play. And our pig head is fully enclosed at that point. Looking good. Let's turn off this template flag. Nice. You know, in fact, I don't know if I really want this other point now that I see it. Now that I went so far as to increase the substeps, maybe I just want it to be coming out of his mouth and his mouth only. Yep, that seems cool to me. The next thing I want to do is actually maybe use this to create some sort of particle geometry that kind of grows across. I mean, like, we do have, these are basically particles at this point, but we could create something a little bit more interesting. What we could do is we could create an attribute and transfer it back onto some other scattered points on the pig head. And I like to do this because what I can do, if I create a new scatter independent of the original scatter in which this solver is happening, I can actually control the density of this scatter independently of the scatter of the infection. So let's do that. I'll throw down a scatter node here, and I'm just going to bring the pig head geometry that we had initially. Oops. Yeah, like that. That works. And here, I'm going to scatter some more points. I'm going to scatter on this one, maybe I'll scatter 10,000 points, and I'll set the relax iterations. I'll turn those off. The next thing I need is some attributes to scatter. So I'm going to throw down an attribute create. over here, we're going to create the A attribute. Just keep it simple. And we're going to give it a value of 1. I'm going to alt drag this over here and initialize the A attribute to a value of 0 so that it can transfer smoothly. Then I'm going to throw down an attribute transfer. In the left-hand side, I'm going to wire this guy, right-hand side, that guy. And by default, it's going to transfer everything. I just want to select the point A attribute to transfer. Then I'll throw down a visualize node. And set that visualize node, set the display flag, go up here to the visualizers tab, and set the attribute to A as well. So now if I go to the attribute transfer under the conditions tab, I can bring down the distance threshold and just maybe bring up the blend width slightly. And the reason why another reason why it's cool to actually take your infection and transfer it is that you get this sort of feathered edge using the attribute transfer that allows you to use the varying value of that attribute to kind of drive some more interesting behavior. Let's set that up. What I could do now is if I threw down a attribute randomize, I could randomize the p scale of this attribute, and then we could use it to kind of create a VDB mesh later on. To visualize this ahead of time, what I'm going to do is throw down a sphere and a copy to points. Before I wire everything up, I just want to set some values on the attribute randomize so it doesn't blow up right away. Attribute I want to randomize is actually going to be p scale. So I'm going to change that to p scale, which is a one-dimensional. And then I'm going to choose to do a custom ramp like I like to do. And I'm going to fit the 0 value to 0 and the 1 value. Well, actually, I'm going to turn on fit value 0 and fit value 1, but I'm going to change them. I want my 0 value to be not quite 0, but maybe a small number like 0.004. These are numbers that I found out earlier seem to be a good size for my setup. And I'll set the upper value to 0.05. And then I just like to notch this over to the right a little bit. Maybe bring it down slightly. This just basically redistributes these random values so that there's just like a lot more small values and just a few that end up being big like this to the upper value, the upper limit of our range, which is 0.05. Okay, so now if I wire this into the copy to points and wire the sphere in here and select it, I'll turn on pack and instance and turn this on, and you can see that we get all these different random sized spheres, which is great. Now what we could do is use this attribute that we're transferring to control the scale additionally on top of the scale that we've already provided in the attribute randomize. So we can do a multiplication operation using A. So let's go and create a point fob. And I'm just going to dive inside here. And maybe what I'll do is I'll keep the copy to points visible up here so that when I go inside, I can kind of see the effect of what it is that we're doing in here. So inside the point VOP, we're just going to want to multiply the p scale times that A attribute that we're transferring, just so that we get that gradiated edge that allows these spheres to scale up as they're multiplied by that A attribute. So I'm going to bind. And I'm just going to, right away, I'm just going to copy and paste this. So I've got two of them. And the first one is going to be A, the A attribute we created. And the second one is going to be the P scale attribute. And now I'm going to just multiply them together. So A in the first one, P scale in the second one, doesn't matter for this, which order they go in. And then I just want to bind out, so bind export this time. And then throw p scale up here in the name. Wire the multiply out, and you can see that all those spheres have shrunk down. And if we hop out here and click play, you can see the spheres are actually growing. Instead of just popping into existence, they actually have a little bit more life to them, which is nice. So the next thing that I'd want to do is actually, let's mesh this. So now I'm only going to use this copy to points over here as sort of a way to visualize, what is happening with our particles. But the way I want to actually treat it is I want to use a VDB from particle fluid. So this node is actually buried inside the particle fluid surface that we were messing around with in the flip chapter. We're basically going to treat this like it's a fluid surface, taking a bunch of different random p-scale values and just sort of melding them together. So let's do VDB from particle fluid. Just going to throw this down here. And it's going to read these particles and try to create SDF out of it. It's a little bit too low res at this point. So I'm going to just, I'm going to turn off resample input. And I'm going to drop the particle separation down to 0.01. You can see there it starts to create this nice kind of blobby looking effect. I want to increase the voxel scale, but I think I also want to increase the influence scale a little bit more of a distance in which they start to interact and create a surface with one another. And I also want to increase the droplet scale, something like that. In fact, maybe 2. We'll see. I kind of liked how it has some gaps in it. So the next thing I would do is throw down a convert VDB. And that's going to turn this whole thing back into a polygon. We just got to select from this convert to, we're going to select a polygon. And so if we go near like frame 29, I'm also going to, well, maybe I'll go forward a little bit just so that there's a little bit more creeping out. Also, what I'll just do is throw down a merge so I can see my pig head together with my new infection surface that's happening. So I'll bring another, I had this notch over here. I'm just going to bring another one down here and merge it with our convert VDB. Yeah, let's just view those together. I think that we really ought to turn this into a color that looks more like a true infection. So let's throw down a color node so we can see things clearly here. And maybe we'll select this nice green color that they have here, maybe darken it up a little bit and hue shift it towards this sort of rotten color like that. As you can see, the pig head has this terrible infection that's growing out of its mouth and is just out of control. I think that, because this is kind of slow at this point, I'd throw down a file cache and do the usual. We'll throw a file cache here. I'm going to name it my usual scheme, which is hip slash. I'm going to change this geo folder into a cache folder. And then I'm going to do $os / $hip name. Just like to insert those before. And then have it be hip name $os $f.bgo.ic. Just the default actual file name, but I like to bury this stuff in its own little folders because I tend to write a lot of caches and this keeps things organized for me. In the interest of time, I'm only going to cache out to maybe frame 120. But I'm noticing right now that I kind of want it to come maybe from this corner over here. So let's just go while we got the time here. We haven't really done anything. We haven't committed to anything too heavily. I'm just going to take this add node here. I'm going to grab the manipulator for it. I'm going to turn off that other one. I'm just going to bring this add node down here and maybe highlight the ray and template the test geometry. And I'm just going to grab this point and move it around until I get it into a good position for the corner of the mouth. I can see that it's sort of hiding in there a little bit. I want to bring it definitely out here and maybe just slightly up. Really just get it in the corner of this mouth. So I'm just going to bring it in a little bit and maybe down a little bit like that. And let's see what that gets us. I'm going to go back down here to the, let's go over here to the solver. And I'm just going to go back to frame 0, click play. And let's see what that looks like. Now we can see the infection is sort of coming off to the side. I kind of like that it's coming around this side of the head first before it actually makes it out the other side of the mouth. So you get a little bit of asymmetry there. And I think that for the interest of this thing, I'm only going to cache it up to, maybe just frame 48. So let's go back over here to our file cache. I'm going to rename this file cache because it's going to actually name my directory based off of it. I'm just going to rename it infection surface. And I'll just right click on the end frame, delete the channels, and set it to frame 48. And we're going to click save to disk, and I'll be back. All right, and that cache is done. I'm just going to hit the merge here. I'm going to say load from disk, and I'm going to set my end frame to frame 48, and let's just play it back. I've got a template flag on somewhere. I'm going to turn that off. Let's go back down here, and this is our amazing infection system. Disgusting. Nice. As you can see, it's just growing across his mouth and across his face, and there's just something wrong with that pig head for sure. So I hope that you found that example a little bit interesting. I think that at this point, it might be a nice exercise to turn this into a digital asset. I actually have done this for myself. I use it all the time because I find that it is much nicer to spread an attribute across the surface using an infection system, because you'll see that it isn't just as basic as starting with like a spherical fall off, or a spherical effector, and having it mess with attributes. It'll actually respect surfaces and crawl around them. It doesn't take shortcuts. It has to literally crawl along the surface to get through. In order to get to the other side of an object, it isn't going to just propagate through space. It's actually going to have to crawl around the edges, and that can be really handy in most situations. I find that almost every effect that involves with spreading of attributes looks better when you do it by having it crawl along a surface instead of just a spatial, spherical, or linear fall off. So I would challenge you to turn this into a digital asset, add it to your library, and use it as often as you can, because it's super powerful and super fun and effective to get a bunch of different cool looks. So I hope you thought that was an interesting lesson. And in the next lesson, we're going to look at just a little bit of Vex coding language. So stay tuned for that.